Okay, welcome everyone to today's Lunch and Learn. We have Dwight Taylor, who's going to be presenting today on optimizing your Tableau workbooks, part 3. As a reminder, please fill out the survey. I will send it out after sometime this afternoon. So thank you, and with that, I will turn over to Dwight. Thanks, Dwight.
Thanks a lot, Tawana. Good afternoon, everyone. Appreciate you taking the time out of your busy schedule to join today's Lunch and Learn. Today's Lunch and Learn is going to be relatively quick. I want to cover a topic, and I'm hoping, the reason I want it to be quick is I'm hoping for some feedback from attendees. In the series of optimizing your Tableau workbooks, there are a set of stable techniques that can be used to optimize and make sure your workbooks are running and very fast and engaging and interactive. Today's topic, I'm going to use a data source that is not a JLL data source, but the reason I'm going to do that is because it's rather bulky, and I'm not familiar enough with JLL data sources to find a really sizable data source. When I say sizable, I mean, more than 500,000 rows of data. I have some databases that I own that sort of use that. So I'm going to use data that's not JLL data today in today's example. That's one of the reasons why it's not going to be very long. The other reason is that I'm hoping we can, or maybe I can get some participation from some of you on the call to talk about ways of optimizing your dashboard with the technique that I'm going to show today. Now, I will say this, because I know that Tableau sells its software primarily to non-technical users. The technique that we're going to talk about today does involve coding SQL, but I'm not suggesting that everyone who uses Tableau needs to learn how to code SQL, nor am I suggesting that because you joined this call that you need to learn how to program SQL. But the technique does involve this, and I'm going to demonstrate something in Tableau that sometimes can be, I think, misleading. Okay, and so we'll just dive right in. I'm going to start with a Tableau performance tip, and each one of the Lunch and Learns that are focused on optimization will have a performance tip. This performance tip is very simple. The fewer rows of data you have, the better Tableau dashboards are going to perform, period. Full stop. Fewer rows of data, better performance. I know that I've been doing a lot of work with the Global Innovations team, who has been really spearheading and vetting out the new data lake for JLL. And for those of you who may not be familiar with that term, basically, a data lake in an organization is an ingestion point where data that's coming into the organization can be dropped. And it's sort of automated, self-service, but at the end of the day, once that data is ingested, users can then connect their reporting and analytic tools directly to the data lake. And over time, that data lake is going to grow to a mammoth size. It's going to be huge, right? This is the world of big data and even bigger data. And so as we approach these type of systems being available to us with tools like Tableau, the reason I picked this topic is because I think it's, going to benefit some of you down the road, if not those of you who are using large data sets today. Okay? All right. So let's get into today's topic. And we're going to talk about data shaping, right? So I have two charts here, and these are just plain worksheets. A line chart, you can see one metric is responsible for the data point of the line, right, where it appears. Another data point is responsible for the thickness of the line. And we can see that, there's only one line on the chart that really is showing some type of performance relative to thickness, right? And that's this segment here. The reason reason I labeled this chart non-optimized is because that's exactly what it is. I created this chart simply by connecting to a data source. I created a Tableau server extract and created my chart, which is the normal sort of process flow when you work with Tableau. And we're going to walk through this so I can sort of demonstrate the benefit of this technique. And the technique is reducing the rows of data that you actually ingest into Tableau before you begin to build your visualizations. Let me say as a caveat before we sort of get into today's demonstration, I don't recommend attempting to reduce data before you have completed the data discovery and explored the types of visualizations you want to create, and more importantly, at the end of the day, the story you want to tell about the insights you discovered during the data discovery and, data analysis process. So just to be clear, and I'll actually put another slide in here, and I'll distinguish these sort of milestones along the creation of a data visualization. Historically speaking, in my mind, it starts with data discovery. You have access to some data. You don't really know what the insights are. You get access to Tableau, and what you do immediately is simply connect to that data. Now, Tableau facilitates you creating graphs and charts instantaneously as soon as you can connect to the data, but that doesn't necessarily uncover the insight immediately, right? And so data discovery is really, exploring dimensions, exploring measures, exploring data quality, exploring data completeness, exploring the volumes of the data, things of that nature. I categorize that activity under the data discovery activity. Once you get past that and you're sort of, have gotten familiar with using your data inside of Tableau, then you really get into the data analysis phases, right? You start doing things like cohort analysis and correlations, and you begin to investigate measures and contributing factors to maybe the performance of a measure and things of that nature. I consider that data analysis, right? And then the final phase of data analysis, once you've discovered those insights, you then, arrive at your storytelling. And this is where, you sort of perfect your dashboards, you optimize them, you make sure that the story is clear, that color usage is appropriate for what you're trying to highlight, whether good or bad, and then you start building dashboards, right? So 3 phases to doing that, and what we're going to focus on today is once you get to that 3rd phase and it's ready for, you're ready to make your visualizations and make, prepare them for prime time, right, for the mass audiences viewing them and then benefiting and hopefully making better decisions based on the insights that you discovered. This step is a final step, right? So you don't want to do this too early in the process, because if you do, you'll find yourself repeatedly having to go back to your data source to add additional items. Okay, so we have a non-optimized data set here with this visualization. I have the same visualization optimized, okay? So the difference between these two is not much, right? There's a couple of dimensional elements that I'm excluding from the non-optimized that I can exclude from here as well, but the visualizations are the same. That's not what's really significant. What's most significant about this is the volume of data. So let's get into the demonstration portion of today's Lunch and Learn. And what I'm going to do is highlight these 2 tables, right? There are 2 tables here. This connects to one of my personal SQL servers out in Azure. And what I've done is brought that data right into Tableau desktop. And what I want to do is start by showing you the number of rows for each data set. Let's see how many rows we have. Okay, so for this data set, we have 66,817 rows of data. Let's create a new worksheet, go with our optimized data set, and check how many rows we have. In this data set, we have 164 rows. Now, what I want to actually do is take take a look at performance for both of these dashboards and see if there's actually a performance gain, because that's the objective of today's session, right? Less rows equals better performance, right? So let's verify whether that's actually true or not. In order to do that, I'm going to save our workbook on the non-optimized data tab. I'm going to close. I'm actually going to delete our data. I'm going to delete the Tableau cache on my system so that I ensure that, you know, I don't have any cached data out there skewing my performance recording. I'm going to just delete that folder, and then we'll record the performance of the first tab, and we'll record the performance of the second tab and take a look at them both to see which one performs better and if there's a significant gain. Now, if we remember what I stated about the row counts, one row, so the performance that we're about to record right now has 600,000 rows of data. 600,000 rows of data in it. All right, so let's stop the performance there. And both of them are in Tableau data extracts. So we have 600,000 rows in one and 160,000 rows in the second, right? But now they're in the same workbook, so this is sort of a spotty test. I would always separate the workbooks in order to truly compare the performance difference. But for today's example, since we don't have a lot of time, I think it's appropriate. So as soon as this comes up, we'll save that. We're going to move to our optimized tab, save the workbook, close that. We're going to remove our caching folder and then record the performance of the second worksheet. How about we save this one actually? Let's save it in our Lunch and Learn folder, and we'll call this non-opt data perf. I want to close Tableau. All right, our caching folder is gone. Now let's record the performance of the second, and then I'll get into showing you exactly what I did to optimize those rows, which is going to be the focus of our session today. All right. Oh, I forgot to actually turn on the performance recorder, so let's do that again. Tableau, performance recorder. And then we open up our workbook. All right. Now, for those of you watching and paying attention, can anybody tell whether the performance is better? I mean, I could basically see with my natural eye that it performed a lot better. And hopefully the results bear that out once we compare the two performance recordings. By the way, I already know the answer to that statement. I just got through making some. Okay, so let's save this, and we'll save this as our, let's go into our Lunch and Learn, and I'll include both of the performance recordings for everyone, and we'll call this the opt data perf. Open up another version of Tableau, and open up our previous recording. So we have our non-opt data performance recording and our optimized data performance recording. And what we're going to do is take a look at both of these, and then talk about the technique and how we actually did that. You know, so you know, the way this sounds fine, but if I want to, you know, reduce the rows of data in my workbook, how do I go about doing that? Great. We're going to answer that question for you. Okay, so here we go. I'm going to just shrink this a little bit so we can sort of look at it side by side, and I'm going to focus on this area so they'll lay on top because my screen is not that big. So what we can see is that for our non-optimized data source, again, reminder, we got approximately 670,000 rows of data. It takes 6 seconds for that dashboard to load. okay, as opposed to 1.5 seconds. So there's a basically approximate 66% increase in performance or decrease in the time it takes it to load when we optimize our data sets. 66%, that is significant, right? Very significant. And basically that sort of should be self-explanatory. So this technique that I'm laying out for you, back to our performance tip, less rows equals better performance, we just proved it. It's true, right? So at the end of the session, everyone will get the recording. You'll get the 3 recordings that I just gave you and the workbook that includes these 2 worksheets so you can validate this for yourself. Now we're going to talk about what I did to optimize these rows, and then it'll become clear why my cautionary statement about doing this after you're done with data discovery and after you're done with data analysis and you've perfected your visualizations, you want to wait until you do this. We'll talk about that. All right, so let's look at this data source. I didn't want to edit that. Yeah, what I'm going to do is, yeah, that's what I want to do. All right, so this data source is simply me, which is what we normally do with Tableau when we're in the data discovery phase. If we have access to a SQL Server and a bunch of tables, usually what we do is just take the table and drop it in there, right? And, you may do 1 or more tables if you have access to multiple tables, and we do an extract, right? That's basically it. And we don't filter anything, because if you watch enough Tableau videos and you attend enough Tableau sessions and maybe even go to the conference, chances are you're going to hear someone say, or you're going to read on a blog or on Tableau's blog or on Tableau's website, that Tableau loves data. So the more data you bring in, the better Tableau is. And that's true, but it's really only true during the data discovery phase. It's not true if you're trying to optimize your workbook, right? It's true if, you want to be able to explore all of your data and, understand where the trends are, understand where the insights are and the outliers are. That's a perfectly good statement and an accurate statement to make. But if optimization is the trick and is the key, then it's not true, right? So essentially what we did for non-optimized data is we brought it all in, right? 670,000 approximately rows of data. Great. What do we do for our optimized data source? After I got the visualization that I liked, how did I optimize this? Let's take a look. First thing is, I didn't bring in the whole table. Why? Well, let's take a look. If we look at the previous data source, the non-optimized data source, the non-optimized data source has 1, 2, 3, 4, 5, 6, 7 dimensions and 3 measures. 6 dimensions and 3 measures. But my visualization that I settled on only uses 2 measures and 2 dimensions. So I'm only using 4 fields out of my entire data instead of 7 or 9 or 10 or whatever it is. It really doesn't matter. And for this data source, it's 4. In Tableau, if the number of dimensions that you have in a data source contributes to what's known as the grain or the granularity of the data. Even if you sum the measure, which we're not doing in our non-optimized data source, going back to that, in our non-optimized data source, we're not aggregating anything. We're just bringing every row of data that we can possibly find into our Tableau data extract. That's fine for data discovery, it's fine for data analysis, and it's usually necessary for both of those phases. But once you optimize, it's not necessary. And in Tableau, I mentioned before that there is a misleading sort of feature in Tableau. I'm going to show you what that feature is in a second. So to verify this, we've got 665,000 rows in our data. If I edit the data source, there's a feature in Tableau called aggregation. Now, this is only available when you create a Tableau data extract, and it is misleading. So, for example, we'll talk about this in a second, but I want to show you how this data is sort of shaped. If I take this date and drop it here, and I look at day, I'm looking at the discrete month, day, and year for this date field, right, new date. If I look at that, I have a bunch of days, right? So the granularity of my data, I think it's pretty much at the day level, right, which sort of makes sense. If you're, tracking some kind of sales or contributions or whatever you're tracking, things being at the day level it sort of makes sense. And it may even be at a finer grain than that. Well, in Tableau, there's the aggregation feature, and it says aggregate the data for visible dimensions and roll it up to what? Now, it says roll it up to year. Year seems to be an option. Now, when you use this, you might think to yourself, okay, Dwight said less rows equals better performance, or whoever that guy was, crazy guy who did all the lunch and learns, he said that. So if I use the aggregate function, this is going to reduce my data rows. That's what you might think, because for those of you who work with data, roll up means less detail. So let's use the roll up feature and see what we get. Creating a data extract may change the data displayed in this workbook. Okay, we're not worried about that. So let's do it and go back to our sheet. What we're trying to determine, and this will take a couple seconds, is whether Tableau, using the aggregation function when you create a Tableau data extract, is going to reduce the rows of data. Now, I'm counting the rows of data here, and I'm already past 665,000 rows of data, even though I turned on the aggregate feature. So if we look at our row count, let's blank out our worksheet and count the number of rows in our non-optimized data source. Wait a minute. We still got 665,000 rows of data. What exactly did it aggregate? Well, that aggregation function or that aggregation feature in Tableau is not designed to reduce rows. It's designed to populate your TDE with data up front. It's the same thing as right-clicking this, going down to Extract, and choosing Optimize. Choose Optimize. Tableau pre-calculates a bunch of stuff about your TDE so that it's sort of quicker to get the values. But because that crazy guy said less rows is better performance, doesn't really give us the bang for the buck we're looking for. So now let's talk about the optimized row set. After doing my data discovery, after doing my data analysis, I know what visualization I want to show, and I know what dimensions and measures I need. Now, we've already determined that the column new date, which is a date, is actually aggregated, or the granularity or the level of grain for that dimension is day, right? So what I'm doing here is I'm going to simply take the year of that column, and I'm going to set every date to 1-1. I don't really care. The reason I'm doing this is because if I have a text column that has 1/1/1/year, Tableau is going to automatically assume it's a date, even though it's a text column, right? Because I'm converting it to varchar and, concatenating a character string to this. So it's not a date value in my SQL, but Tableau's going to think it's a date when it comes in and treat it as such. The next thing is I'm taking the dimensions that are important for my visualization and I'm summing some things to actually truly aggregate them at the level of detail that's important for my visualization. So basically, I'm writing a query, right? And I am not, most importantly, you know, we're aggregating, but the reason this is aggregated and you can't change this is because we're using a custom query. And the custom query contains a group by. Okay, so Tableau is smart enough to know that if you put in a custom query and this custom query is grouping by something, then Tableau knows you're aggregating. It's not something that I checked. This will be checked by default. And if I uncheck this, it won't make a difference because I'm determining the number of rows that come back based on the type of query that I'm sending in. Now, for those of you who don't want to program raw queries, you also have the option of creating a view on top of a base table, right? A view will allow you to aggregate data and then you can attach to the view and you don't have to worry about actually writing raw SQL code in Tableau. In addition, you know, there are, let me put it like this, there are articles you'll find with regards to Tableau that warns you about writing custom SQL statements. I'm not going to get into it, but there are certain Tableau features that don't work well with custom SQL statements, okay? All right, so that's a second tip. Anyway, so I'm writing a custom SQL statement, and this is going to aggregate my data. And in essence, what it's going to do is cut my rows down from 665,000 to 164. All right. At the end of the day, Dwight, why is this so important? It's only 4 seconds, right? You acting like you done solved the world's problem. Well, I'm going to encourage that comment that I just said to myself, having this conversation with myself. What seems to be 4 seconds and seems to be insignificant in a visualization that is very, let's say, light on complexity. This is a really simple visualization. When you begin to think about dashboards that have multiple worksheets on them, and the dashboard is doing multiple things, and there's interactivity, and you're using the use as filter, and you have action filters, and you have all type of stuff going on, that 4 seconds changes into more like 15, 20 seconds. And so when your user loads your dashboard for the first time, instead of them seeing results regardless to whether Tableau server is actually optimizing your view via caching or not, if it takes your users 30 seconds to see your dashboard, they soon begin to get exacerbated. And if it takes longer than that, you have what's known as view abandonment. People just stop waiting and they move on to something else because it's taking too long for your view to come up. So what seems like 4 seconds in a very simple visualization gets compounded when you create complex dashboards or you have more data marks on the screen. So, for example, this worksheet only has 91 marks on it total, right? If you change that to 5,000, Tableau has to draw 5,000 points on a chart, and it gets, you know, the time that it takes to load increases significantly. Out of all of the techniques for speeding up Tableau dashboards, here's what I share with you in 5, 6, 7 years of experience. This is the #1 technique that gives you the biggest performance boost. It's #1. The #2 technique we'll talk about in the next optimization is how much stuff you have in your workbook, right, outside of optimizing the data. So I told you we wouldn't be long. We're at the 30-minute mark. I think I've sufficiently gone over the technique and demonstrated the performance boost that you get, 66% performance increase or load time decrease by reducing the amount of data from You know, 500,000 to 100. That is significant in Tableau. Think about it. Every time your users go to your dashboard, they come up instantly, regardless to whether Tableau server is caching it or not, because you've optimized your views. That's the Shangri-La of Tableau land, and that's what they show you when you look at a Tableau demo, right? Because the data has been optimized for the demo, you can have those same results. Okay, questions, discussions. Hey, Dwight, how does this apply to my XYZ scenario? I am open for that. Otherwise, I will include this work. I can't include this data because you all can't have access to this data. This is actually real data, and I've changed the name of the metrics and stuff like that. But I'll do a sort of similar scenario with the sample superstore data, okay? And once again, the sample superstore data is only like 10,000, 30,000, I don't know. It's a very small data set, but the same technique will be demonstrated in the workbook that I give that will be available in the ongoing learning website. Okay? No questions? Wow.
Hey, Dwight, I got one for you. You know me. I'm always wanting to ask you something.
Absolutely. Hi, Rob.
So I love how you did this. It's a great idea to get rid of all that data. What if somebody's using a report like this and they really have one that shows everything year by year, and I've got another one that shows what happened in the last year? Now, since we aggregated it up, what's the best way to bring in like the day by day for the last year and join it to this without taking a performance hit?
So I need you to explain that to me again. It sounds like you're...
So let's say we're building a dashboard and this is one of the panels, right? And then we got another one that shows for the last year everything that happened by day.
For the last year? Okay, so there's...
Right, for the most recent year.
So the most recent year by day.
Right, because we lost that granularity since we summed it up, which is good and totally understand it for the performance reasons. But sometimes we want to drill into that last year. Cool.
Absolutely. Absolutely. So you know what I would do, Rob? Here's what I would do. I would create 2 different data sets, because remember, less rows is more. You have 2 options, right? The first option is you could leave the date granularity in the data source. If we do that, we get back to 665,000 rows of data, defeating our performance increase that we gain by reducing the rows of data. But what we're doing for, how many days are there in a year, Rob? You're a smart guy.
365 and a quarter, Dwight.
Wow, 365. So we have good performance. Our total data set is 665,000 rows of data. We're looking to demonstrate the performance of data daily for the year-to-date value, right? That's what we're looking to do, right? On December 31st, on January 1st of the next year, we should have 365 rows for the previous year, right? How many rows is that? Well, that's 365 rows of data. It's a lot less than 650,000. So my approach would be, if I've got 2 charts and I want to optimize them, instead of bringing in one data source that's 665,000 rows of data, 2 data sources against the same base table, one that has 164 rows and another that has 365 rows, for the extra work of having multiple data sources in my workbook, I get the performance boost. The value proposition is high.
I love it. That's what I was hoping you'd say. I didn't know if the join itself then would add more hindrance than performance gain.
Joins degrade performance. It doesn't matter whether your data is high performance or not. The moment you join one something to another something, performance goes down.
I got you. So just leave them separate, and then the different panels, one will show the year data, one will show the over time aggregated by year. Beautiful.
Exactly. And with the Tableau filter option to filter across data sources for the same column, you could easily do that. So, for example, we have one data source that has a date dimension by day, where the days are different. A second data source that has another date dimension, but it's all the first day of the month. But because they're both date dimensions in Tableau, you can have a filter that filters both panels across both data sources with just the year or the day or the month or whatever value you want. and that would well, you'd want to probably stick with year because your one data source doesn't have day or month, right? They're all just January 1st, but you could do that. And so you still can get your interactivity across the two data sources as well. So that's what I would do. Great question, Ron.
Great answer. Thank you.
Yeah. Anyone else?
I have a question. I probably missed it, but when you did the 1/1 plus the year, of the date, why did you do that instead of just doing year date and having a number?
Right. So in Tableau, and if you do year of date, what Tableau will recognize that as a number, and it won't easily convert it to a date. It won't be easy to convert to it because it's just a number. It's just a year.
And why do you want it as a date?
The reason we wanted it as a date because I wanted to show a time series line chart, right, across years. And in order to do that, you have to have a date in Tableau. I didn't actually convert it to a date. I kind of just did it. But if I convert this, change the data type to a date, right, and I just bring in year, it gives me a time series chart, right? So
I didn't see anything change on your screen. I don't know if anybody else did.
Sorry about that. Keep only. Can you see my screen now?
I'm seeing something, but it might be paused. I don't know about anybody else.
Can I get someone to speak up and see whether they can see my screen and you see 2004, 2005, 2006?
Yes.
Yeah, I see you.
Oh, you know what? I lost my connection. Sorry. So it's just me.
Okay.
Coming back.
So I can answer your question. Don't worry. The reason I concatenated 1/1 is so that Tableau, I would be able to convert that calculated field into an actual date in Tableau. By the way, when Tableau recognizes a column as a date, there's a ton of built-in functionality that Tableau attributes to that dimension. And so it's really important that when you're bringing in your data, if you have a date, if Tableau doesn't recognize it as a date, you might want to shape your data so that Tableau does recognize it as a date so you get all the built-in functionality that comes with date type columns or date type dimension. Okay?
Interesting. Good. That makes sense. Thanks.
Yeah, sure. Any other questions? Well, let me just say this, this is one of the shorter lunch and learns that we've had, but I will promise you that for those of you who are having conversations about performance of your dashboard, this is one of the techniques you should probably start with. Second on the list, well, okay. For JLL, what I've seen, data volumes is never the challenge because you all have pretty much small data sets. I haven't seen one data set that has 100 million rows of data or even 10 million rows of data, not yet. So for, in the next Lunch and Learn, I'm going to go over the #1 performance tip for JLL specifically. That's a plug for the next Lunch and Learn, the 1 o'clock Lunch and Learn. I think. Joanna, do you know whether the next Lunch and Learn is optimization? 11 o'clock is optimization or the 1 o'clock?
It's usually the afternoon is optimization. Let me just check real quick.
I had that up. Anyway, I won't. I'll figure that out.
The next one on Tuesday is data shaping with Tableau.
Yeah.
Okay, so data shaping is 11 o'clock, Renee?
Yep.
Correct.
1 o'clock.
Right. Okay. Optimization is always in the afternoon.
Okay, great. All right, so the next optimization, if you have a workbook, you're using Tableau at JLL, and you have and you want your workbooks to perform, you want to be at the next optimization Lunch and Learn, part 4. We're gonna really dig in. I'm not gonna use anyone as a guinea pig. I'm not gonna use your workbooks as a guinea pig. I'll create a horrible workbook and we'll use that, but it's going to be a direct application to all of the workbooks that I've seen at JLL, okay? And I've looked at all of them. So it's going to be really fun. That one's going to be a really
What if you want to, hey, Dwight, what if somebody wants to be a guinea pig?
That would be even better. Man, I mean, you know, we'll get some photos. We'll get, like, you know, family name, family photos, and we'll take their workbook and just make a session of it.
That's not quite what I meant, but
I'm kidding about that part. But yeah, so I can build a workbook, or if someone wants me to take their workbook that has a performance challenge, and you want to use that as the subject of the Lunch and Learn, I would be perfectly okay with that. Absolutely.
when I send out the email.
Now, I will say this, here's what I want to avoid. We only have an hour. The technique that I'm going to go over is just one topic, because I think that's the only, that's enough for 1 hour to really, cover a topic as thorough as I'd like to cover it. So, the challenge may be, there could be 4 or 5 areas, which is sort of traditionally normal, what I've seen in most of the workbooks that have performance challenges. There are 4 or 5 areas that need to be addressed. I'm only going to address one, so that may be a sort of drawback.
Okay.
Okay, everyone, listen, thanks for your time. Should you have any questions, the Ongoing Learning website will be out there. The recording of this video will be out there. We probably should edit out the joke. I don't know if that's possible.
Oh, no, I'm keeping that in there.
Okay, yeah, that's evident. All right, thanks, everyone, for your time, and I'll make the quick changes to this workbook. I'll create these same worksheets, make the changes, and get this to everyone so that you can see this example. Okay? Thanks for your time.
Thanks, Dwight. Thanks, guys, for joining.
Thank you.